Today we're dealing with the function f, which is defined by f of x equals this crazy integral. This is kind of like the most common function everyone uses every day. But basically you've seen this function before, so let's get straight into the integral. A pretty nice trick for integrals like this is just multiplying and dividing by something. And that would be basically to introduce a tan and a sec instead of keeping it in terms of sine and cosine. So the way we do this, well, we can do it in terms of factoring. We can factor out a cos t from this thing inside the square. So that means we can write this now as cos t times 1 on cos t plus x tan t. Just take a moment to check that this matches. Okay, so now we can take this cos t outside of the square, giving us a cos squared t. Okay, so what is 1 on cos squared t? Well, that's just sec squared t. So we can put that in the numerator, multiplying both terms by sec squared t. So we have sine t times sec squared t, and that's the same as sine t times sec t times another sec t. And sine t sec t is obviously tan t. So here we have sec t tan t. Keep in mind here x is a constant, in terms of t at least. So we can take x outside of the integral like this. And now we have this in the perfect form. The top is the derivative of the thing inside the square, with respect to t at least. So this is just going to be a classic reverse chain rule. It will be minus 1 over sec t plus x tan t. And obviously we're integrating from 0 to pi on 2. So you might think, okay, how do we sub in sec pi on 2, tan pi on 2? Well, we're just taking a limit here, so we can just rewrite the thing in a different way. We have minus cos t over 1 plus x sine t when we multiply by cos t. So now it's a lot easier to put in the bounds. We have 0 when you sub in pi on 2, because cos pi on 2 is 0. And we're just going to minus this thing here where t is 0. This kind of just simplifies to x times 1. And hopefully you can do this last step here. This is just going to be x. So all of this nonsense gives us the function f of x equals x. So if you ever need to write the identity function in a strange way, you can use this. I don't know how this is going to help you, but it's pretty cool.